Get test on Monday. If I don't have your quiz, it should be on that table up there here in the next minute or so. On it, on the quiz, your picture, could you figure out that it looks something like this? And I've been talking the whole time about students make these problems a whole lot harder than they have to be. Those two that I just handed that to are going to help me out. Grab it, Nick. I didn't hand it to Gavin. The first thing, what's the, first we can see some of the picture, right? Can we see this letter? What is it? D. This letter? We can't see the other two, right? But the very first thing says what? The very first given.
BD bisects
Some angle, right? So BD bisects some angle. Just looking at this, where's B have to be at if it bisects an angle? It's got to be here because either this angle's being bisected or that angle's being bisected. B can't be down here. BD wouldn't bisect an angle if it was down there. So what's that tell us about this letter? Probably C. It says BD bisects some angle that we can't see, and it also says BD bisects some other angle that we can see, right? What angle does it say it bisects? Please remember, my first block class having trouble with this. When you're naming an angle, the vertex has to be the middle letter, A, D, C. So that's that angle right there. If that angle is being bisected, what do we know about these two angles? It says it bisects some other angle. What's the only other angle it could be bisecting? So what do we know about these two? Is that enough to say these two triangles are congruent? No, not quite. What other given information did they have? There was none, was there? So we got to come up with something on our own. What are the two easiest things to come up with on your own? Reflexive property. Anything equals itself. And what's the other one? Vertical angles. Those are both real easy. If you can't come up with those, you've got to be able to come up with some of this stuff. It's not brain surgery. All right? Do we have either one of those here? Anything equals itself. Now, a few of you were asking me, are we using angle side angle or are we using angle side?
Angle side angle.
So to tell the difference between these two, you got to know which angles we're dealing with. If we're dealing with this angle, if I separate this off, I'm dealing with this angle and this angle. To be using angle side angle, it's got to be the included side. So it's going to be the side that's between the two angles. Which side is between these two angles? Do you see how BD, that segment, sort of connects those two angles together? That's the included side. Is that the side that we're using? So are we using angle side angle or angle angle side?
Angle side
If they told us that this side was congruent to that side, and we didn't have that middle one, then we would be using angle, angle, side. All right? Is that enough to say the two triangles are congruent? Are we trying to prove the two triangles are congruent? No. What are we trying to prove? Segment AB was congruent to something, right? Now, several of you had trouble with this. When I match up these two triangles, my two triangles look like this when I match them up. What do I do to match them up? How do I get the orange one to lay on top of the green one correctly?
Just rotate down.
Just flip it. This time it just flips. It doesn't, it maybe could rotate around and still match up, but that's not the way we got it set up, is it? Because we want this angle to match up to that angle, this angle to match up to that angle. So you're just flipping it down. So AB is going to match up to what? How are we going to know that in our two-column proof? What's going to be our reason for that? Once we've proven the triangles, what's that next reason always have to be? Corresponding parts of congruent triangles are congruent. It's always going to be that. All right? I'm going to write this real quickly. Segment BD bisects angle. Somebody help me out. What angle did they say? ABC? Is that right?
Yeah.
And the other one we couldn't read, but it's going to be ABC. How do we know that? As soon as you see an angle's being bisected, what'd you tell me? What'd you know about these two angles? Help me out. Somebody name that top angle right there. ADB. Remember, the vertex has to be in the middle. Angle ADB. How about this angle? VBC. Does everybody agree with that? Making sure that you're using your symbol. As we go through the notes today to review for this test, there's like 10, 12 reasons. We've used those same 10 or 12 reasons over and over, and we haven't used anything else. The reason here, what was the key idea in number 1? So if an angle bisected, what do you know is happening to it? Split into two congruent angles. Do you think we're ever going to use that again in this class? Over and over and over again. Like I said, we've only learned like 10 or 12 actual reasons that we use in these two-column proofs. And we're using the same ones over and over and over again. So every time you see an angle being bisected, that's probably going to be a reason. Down here on the other end, angle ABD is also congruent to angle CBD. How do we know that those two angles were congruent? Now, I don't want you to do this. I'm going to because I want to rush through this, all right? Does everybody understand that? So, Zach, do not do this on the test on Monday. If you do it, I'll mark it wrong. Don't come back to me and say, well, you did it. No, no. What?
Can I try it big enough so it covers both of them?
No. Now, the reason I would allow this, the reason there was only 5 steps on there instead of 6, is because the book did this. They just put those two in the same thing. All right? I don't like it when you put them in the same thing. That's another pair of angles. Is that enough to say the two triangles are congruent? Sorry, mine's so sloppy. We needed something else. What was something else that we came up with from our head? BD is congruent to BD. Notice, I'll yell at you if you say it's equal. Who cares? I will yell at you if you can't pick that out. That bothers me that you can't say, hey, look, they share that side. It's the same thing. How do we know that? We're probably never ever going to use this again. Sorry, I'm not supposed to be sarcastic. As a pair of sides, is that enough to say the two triangles are congruent? Name the triangle on the top for me. Doesn't matter how you name that first triangle. All that matters is that you match it up. What's A in that top triangle match up to? C. What's B in the top triangle match up to? And what's D match up to? And how do we know that those two triangles were congruent? Angle, side, angle. Please remember, if your statement is two triangles, your reason has to be one of those 4 3-letter abbreviations. Are we finished? If we're not finished, what do we know this next reason has to be? It's always going to look that way. And our statement was what? Segment AB is congruent to segment BC. On the test, I will not put any elephant pictures on the test covering it up. I'm not going to make it that difficult. I just wanted you to see that even with that elephant there, could we still do this whole problem? How many points would this be worth on the test? How about a calculator so you can help me here in a second? Count for me. Should you get this one? That's 1, right? Maybe you missed that one. Maybe you don't know what bisects means. If you miss this, you're probably going to miss that, right? Same thing on this, same thing on that. Should you get this one?
Yes.
I hope. How many points is that? 3, 4. Should you be able to match up the triangles?
Yes.
Yeah, maybe. You might, some of you are trying to spin it instead of flipping it. You know, pick one or the other. Let's say you get lucky and you do it the correct way. So now we're at what? 5, 25% chance. Maybe you miss this one. Maybe you put angle, angle, side. You guessed wrong. You got close, but you guessed wrong. So we're at 5. Should you be able to get this one? That's the prove statement. So there's no, it says prove right here. You know that that's going to go in your last statement. Should everybody get this one? Yeah, if you're proving segments or angles, what's your last reason have to be? So how many we got? Somebody help me out. What's 7 divided by 12?
58.3.
So about 58%. Now I know that's not going to make a whole bunch of you happy if you get a 58% on this test, but is a 58% better than a 0? A whole lot better. 58 times better, right? 58 times 0 is 58, right? Oh, it's not? All right. Whole lot better. The only thing that I said that you had to learn this year that we counted in this was that right there. Anything equals itself. Everything else, all you're doing is recopying stuff. So if you get your test and one of your answers to your 2-column proof looks like this, is that a very smart thing? Don't just leave it blank. That makes no sense whatsoever. All right? On the packet, the CPCTC packet, questions. No questions, just hand them in. It's all easy, Cooper. Easiest thing ever, isn't it? Why are you changing my letter? James, I don't know why you're laughing. Ebersole is going to be dead at some point, and these are the people you're going to have to live the rest of your life with. You better move to
Don't say it.
move to Canada somewhere up in the mountains, the Great White North, and get away from them all. No questions. Everybody understands them all. Spectacular. What you're going to do? Make sure you got the notes. You're going to start a second pile right here. Make sure your names are on them. When you get back to your seats, start copying and filling in these notes.
worse.
I walked in, I looked at Nick, and then I just looked at the great. That was unnecessary. That's better.
That was unnecessary.
That's better.
Make sure you sort of keep them in order, don't mess them up. Ethan, are you gonna be all right sitting back there, Ethan K?
I'm half blind sometimes.
Ethan knows everybody that sits by you normally?
Jamison.
Oh, Jameson's not there. You could move up there where Jameson sits normally if you need to, Dick.
I think I'm good.
You all right? Might need to move Cooper at some point. He's been close to me for too long. I wouldn't do that, Cooper. I like you.
Don't you make the seating charts?
Sure. They get random. Yeah, we get numbers.
Things randomly been over in this part of the whole time.
I wonder.
They're not random like Pastor.
Believe me, Henry, I was wishing.
He doesn't use dice.
That's like 2 times in a row that me and Cooper had to sit by each other.
You guys did it both times. You did it to yourselves. You guys must like each other that much. So both those, no, you guys didn't draw the numbers the second time, did you? My intervention class did it. While you're doing this, so I don't forget, because I'll probably forget at the end, on the review packet that you picked up, there's like 70-some questions. You only have to do 40. But of those 40, no more than 20, you can do more, but you have to do at least 20 multiple choice and 20 of the short answer. You can't do just all multiple choice. I don't even think there's that many multiple choice, but you can't. So you got to do 40, but when I go through and I look at them, I'm only counting 20 of the multiple choice and then 20 of the short answer. You got to do 20 of each.
Do they just do like the first 40? Would that be about right? Mostly.
I don't know, because I'd have to look at it. Then you're going to be a few short, aren't you, Ethan? And did you look at it just a second ago? You're going to be a few short, aren't you? How many multiple choice are there? 26. So you'd be 6 short on your other end. That wouldn't be complete. So you'd have to do 6 extra of the others. So 20 multiple choice, 20 short answer. On this, classifying triangles. 2 different ways to classify triangles. According to the sides of the triangle or according to the angles. A scalene triangle. No sides equal to each other. Did we do a whole lot with scalene? There's not a whole lot to do with scalene because if they just tell you, hey, no sides are equal, well, that doesn't tell you a whole lot. These other 2 we did do quite a bit with. My pen would work. Isosceles. The isosceles triangle has 2 equal sides. Equilateral has 3 equal sides. And we're going to talk more about those later on in the notes. That's naming this triangles according to their sides, those three names. According to the angles, you could have an acute triangle. If it's an acute triangle, all three angles must be acute. If it's an obtuse triangle, how come this says only one obtuse angle?
Because there can't be more.
Can't have more than one angle in a triangle that's obtuse. Because the three angles of a triangle have to what? Add up to 180. And that's one of the key things that we're going to talk about here in a second. So an obtuse triangle just has one obtuse angle. How many right angles are in a right triangle? One. No more than that. Can't have any more than that. Equiangular. If a triangle is equiangular, all three angles are congruent or equal. If it's equiangular, then it's also equilateral. One of the key things, key rules that we learned this chapter, I'm not sure why my pen's not working so well. Three angles of a triangle must add up to 180. Got to know that. I guarantee there's several problems on there where you're going to need to know that. Next theorem here, exterior angle. Which one of these, 1, 2, or 4 is an exterior angle? Some of this stuff that I'm writing down on here, you might want to write it. I will let you use your notes on this test. Some of the stuff's going to be real important. Others, you write it if you think you need it. So angle 4 is an exterior angle. We had a theorem that said this angle added to that angle, the two non-adjacent interior angles, so the two angles inside the triangle that aren't hooked to the exterior angle, have to add up to equal that angle. So if I had this picture, and I told you this angle was 50 degrees, and I told you this angle was 70 degrees. What do we know about that exterior angle out there? It's 120 degrees. These two have to add up to equal that exterior angle. What can you tell me about this other interior angle right here? 60 degrees. What should be true about these three angles together? And they do. So either way that you find it, I'm not going to come back and ask Brianna, hey, how'd you find this? Did you use the exterior angle theorem or did you use the other way? I don't care. Find the correct answer. Next thing we had, third angle theorem. These two angles and these two triangles are congruent. These two angles are congruent. What has to be true about this third pair of angles? They have to be congruent. Nothing really hard about that. Fill in what you need to fill in on this one. Cooper's like 3/4 of the way done with his packet already because he's so smart.
Hey, Cooper, you want me to check them, make sure they're right?
If you're a real friend, Cooper, you tell him, I'll let you use them to see if your answers are correct.
Either or.
That way, when it comes test time, because this little grade of this review packet, it's a grade, but it's not near as important as the test grade, and we'd really like Dylan to do well on this test, right, Cooper? Because we're his friend, right?
No.
You're not. No, that's why he didn't ask you, he asked Cooper. I mean, Cooper trying to help him out. When you're proving triangles are congruent, prove two triangles congruent, it's got to be one of those four abbreviations. Things to look for when you run out. Which of these are the ones that we look for probably first? Vertical angles? Maybe. Just give me one other one. One that we use a lot. Those two, right? We use those two a bunch. I'm guaranteed. Gavin, guess who made the test?
You.
Me. If I'm telling you this, guess what you're probably going to use a lot? Those. I'm not lying to you just because I want to see you not do well on the test. We use those two a lot because they're easy to pick out. Now the parallel lines, so if you see this symbol, I guarantee there is a problem like this on the test. You see that symbol? What should you look for first? Look for that Z. See if there's alternate interior angles and know that they're congruent. If you have two right angles and a problem, what do we know about all right angles? They're congruent. Midpoint, segment bisector, or angle bisector, and we're going to talk about this more here in just a minute. Whatever it is, it splits it into two congruent segments or two congruent angles. Segment addition postulate. Says that segment NT plus segment TH has to equal what? NH. This part plus this part has to equal the whole thing. CP-CTC, corresponding parts of congruent triangles are congruent. When are you going to use that?
After you prove a triangle, right?
After you've proven the triangles are congruent. So if your proof statement says two triangles, are we ever going to use CP-CTC?
No.
If your proof statement says segments or angles, then you know your last reason is going to be CP-CTC. On this one, what we're going to do on this, you might have to get out another sheet of paper if you want to do this. If you don't want to do it, I don't care. That's up to you. We're going to write, I added this to it. That's why it's not on your notes. Reasons. Reasons that we use. When we're doing any two-column proof, what's a reason that you could put in that reason column? Anything equals itself. We're going to list all these reasons, and if Miranda writes this down when she's doing that and she can't come up with a reason, she could look back at this list and maybe come up with it. There's the notes, and this is something that we're actually adding to it, so it could be written on a separate sheet of paper. Another reason. My other class did the easiest one first.
Flexor.
We just dig out.
He was asleep. What? Vertical angles are congruent.
Hey, Mr. Ebersole.
All right.
Yep.
Not trying to sound like an idiot, but vertical angles are the ones that are like across from each other, right?
So if we have this picture,
Go down to like seven.
Got it. Alright.
they have to be congruent. Even though I said that stuff earlier, ask. I won't. If you learn something, that's all I care about. All right? Still haven't done the easiest one.
All right angles.
All right angles congruent.
Given.
That's the one I was talking about. That's probably the easiest one, right?
Yeah.
These are all reasons that we could use in our two-column proof.
That's.
side, 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 etc. I'm not gonna write all the others.
Angle,
That's what et cetera.
But
Yes.
don't even say that to him, because is angle one of them?
Nope.
Oh, yeah. We'll talk about it.
Very sure I put that on the homework sign.
I hope not. Give me something else.
There's more.
Corresponding angles.
Now, those are probably the easy ones. Miranda just said this. This is getting a little tougher, so these are the ones that if you want to write these down, this is why it would be a good idea. If you have parallel lines, those are the parallel symbols, sorry, the three of them. Then, what do you know about corresponding angles? They're congruent to each other, equal to each other. What's another one that goes right along with that? If you have parallel lines, then alternate interior angles are congruent. I'm not sure why I put R in one and not in the other, but. What else? Midpoint does what?
Splits two things into two congruent.
Splits a segment into,
But it could split an angle too.
midpoint can't.
Oh,
If I give you this angle,
yeah, it's talking about bisector.
splits a segment into what?
Two congruent segments.
Two congruent segments. If you're splitting something, if you're butchering a cow, and they send you back bacon, somebody did something wrong.
Well, maybe that's just one messed up cow.
Maybe.
It's a Henry cow.
Speaking of bacon.
I'm not speaking of bacon. Next,
Does bacon come from
if
turkeys?
angle,
What makes bacon turkey?
not gonna say it again, quit. If angle bisected, then what? What's happening to the angle if it's being bisected?
Two congruent or
Split into two congruent. I don't like using parts because right angles using that abbreviation like that, the symbol
It's a lot shorter than
short. What else?
Said there are 12 of these?
There's as many as we can come up with, and we're missing something. I can't remember what it is. Let's see. We got the vertical angles. We got the midpoints.
Ain't there one corresponding?
We did that one. What else? My first class came up with like 12, 10 or 11, something like that.
what'd you say, James? Segment addition.
Segment addition postulate.
Segment is part.
James said that.
Rejection.
I'm not sure why they think that's such a big deal, James. They act like you're not very intelligent. That bothers me that they think that way.
No, we're proud of him for thinking of it.
He's very intelligent.
I know he is, but none of us could think of it, so we're proud of him.
Okay.
I'm still trying to think of turkey.
It's not a bad thing.
All right. What else? I know there's others.
You have perpendicular lines.
Perpendicular lines form what?
Right.
Four right angles.
Right angles. Perpendicular lines form right angles.
Yeah. You look at it.
Well, I don't remember.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 so far. I still think that we're missing some.
Four.
I don't know. Because we're not going in any certain order, so it makes it hard for me to remember, hey, what are we missing?
Well, then, what order would you go in?
Yeah.
There's
not
no
really-
order to go
There's
in.
not really a certain order to go in.
The alphabet.
No,
Don't.
not the way. I have an order.
Just common.
I don't know where the purple rectangle goes.
Dylan, you're not allowed to talk unless you pick up your pencil and you start writing. If I don't see your pencil in your hand, I don't want to hear your voice.
So now you
With
have
the piece of
disguise
paper
your
writing.
voice.
Maybe, so have that list. Maybe we'll come up and we can add some more here in a minute if we remember.
Right.
But if you're doing a 2-column proof and you have this in your notes, and you can't remember a reason, might this be a good thing to refer back to?
Alternate exterior.
We could use that, but yeah, that's what goes right along with these.
Stay like that.
Yeah, but we've never really used them.
It's not important enough, Gavin.
Fill in what you need to fill in on this one. We're going to draw some extra stuff. You're going to have to figure out where to write it. There in your notes. Sorry, one of the parts of the isosceles triangle I left in there for you. Forgot to leave it blank so that you had to write it in. But in an isosceles triangle, what do we know about the two legs? They're congruent. The angle between the two legs is always called the vertex angle. The other two angles are called the base angles, and what do we know about those base angles? They're congruent. The third side is called the base, and this leads me to what I want you to write in there somewhere. Very important on this test. There's several problems on this test. If you know these two rules that we're getting ready to talk about, it'll make everything a whole lot easier. If I have this triangle and I know that those two sides are congruent, then what do I know about the angles across from those sides?
Congruent.
They have to be congruent. And the other theorem says, if you have a triangle and you know that two angles are congruent, then what do you know about
Two sides.
the sides across from them? They have to be congruent. So anytime you're looking at a triangle, if they tell you these two sides are congruent, then you know that these two angles have to be congruent. If they tell you that these two angles in the triangle are congruent, then the sides across from them have to be congruent. Again, very important on this test, because they're going to give you a problem and it's going to look something like this maybe. And they're going to tell you that these two sides are congruent.
Who's this?
The people that made the test. And then they're going to put in something like this angle is 50 degrees. And they're going to say find angle C. What do we know about angle B if this angle is 50 degrees? Nothing? Say it, Jacob.
50.
It's 50. And then if those two angles are 50, can we find this angle?
Yeah.
Three angles of a triangle should add up to what?
180.
So that angle's got to be 80, so on and so on. Fill in what you need to fill in on this, not a whole lot, then we're going to write some other stuff with it. As you're filling in, setting up and solving equations, I'm not going to explain a whole lot on that. Be able to set up and solve equations, that's something that sort of self-explanatory. Out to the side over here, if a triangle is equilateral, what do you know about it?
Equal angle.
It's equiangular. First, if it's equilateral, what do you know?
All sides are
All sides are congruent. Then all angles are also congruent. What do you know about each one of those angles?
60 degrees.
They're always 60 degrees. Might want to draw that picture so that you have it there somewhere. With the two column proofs. First column's called what? Second column? What's your first reason 99.9% of the time going to be?
Given. And what does it mean not given
If I'm doing this two column proof, I get down here to number 4 and it says some triangle is congruent to some other triangle. What's my reason over here going to be?
I'll give you the next one.
What's this reason going to be?
CPCTC.
Every single time. If there is another step. How do you know when there is another step or not?
It's not asking you to solve for the triangle. it's
Right.
asking for the side.
So if your proof statement says two triangles, some triangle congruent to some other triangle, then you stop here. If your proof statement says segments or angles, then you got to go that step farther. On the review packet, Zach, I should just go sit down and shut up. Let you guys just work. Shouldn't I?
Probably.
But,
I mean, if you want to help.
you make me cry now. If I go sit down and be lazy, then. On the review packet, you flip through it and find problems, and we can work them together real quick while we've got time. We got about 20 minutes.
How many questions are there like that?
I think there's 27, 28. Okay.
I just want to know if I did it right.
Did you answer A, B, C, or D? Then you did the problem right. I don't know whether it's the answer is correct or not. Do you want me to do it? Number 8. Problem number 8. Oh, that's not the way I want to go. My triangle might not look exactly like theirs. Close enough. L, K, M. What do we know about this bottom triangle with the way they marked it? The angles are all congruent. Tell me the measure of angle L right here. 60 degrees. I don't know if they care, if we care about that or not. What do we know about all the sides? They're all congruent. This one's 5, so what's this one? What's this one? Let's see, in this other triangle, they tell us that this angle is congruent to that angle. What do we know about this triangle over here then? MKJ. It's an obtuse triangle, that's true. What else? What do we know about those two sides? If these angles are congruent, then the two sides have to be congruent. So if this one's 5, what's this up here have to be? 5. That's a 5. Let's see, what did they ask us to find? Find the value of x? Well, they told us that that side was x plus 1, right? So x plus 1 should equal how much? 5, subtract 1, what's x equal? 4. Is that what they asked us to find? Next question. Problem 10. Problem 10. And once one of you listens to Gavin, I'm not doing all the 2-column proofs, so I'll do like 1, maybe 2, but I'm not doing them all for you.
Talk about all of them.
I know, but that's, as soon as we do one, Gavin, what's gonna happen?
We go back.
Come on now. I've been a teacher long enough to know that we do one and then we'll end up doing two, then three, then four, and everybody just keep going on. Because that's, and I'm saying it up front now so that I don't have to hear the complaining then. They tell us that these two segments are congruent. These two segments are congruent. Says, name two triangles that are congruent to each other. Well, we got a pair of sides and we got a pair of sides. Is that enough?
We have angles.
Which angles?
First
What do we know about these two angles right here?
one.
They're congruent to each other. Which two triangles? Name this triangle over here for me.
H, J, G.
Does everybody see that one? So triangle HJG. What's it congruent to? What's the H match up to?
J.
Be careful.
K.
K,
J.
J,
L.
L. Now, just because we named it this way, does that mean that's the way they named it? No. Is that the way they named it? H, J, G, K, J, L. So, letter C. So we got lucky. Number 11. They tell us this angle's 50 degrees and this angle's 50 degrees, so what do we know about them? If they're both 50, what's that tell us? They're not vertical, but they're congruent. Now, watch on this because this is something that you should know, but Logan may not know it. In a circle, what's that called when I go from the center to the edge?
Radius.
A radius. What do I know about that radius and that radius? They're the same length. They're always congruent to each other. Does everybody see these radius in this picture? So those two are congruent, even though my picture doesn't look like it. Actually, all four of those are congruent, right? What do we know about these two triangles then? They're congruent because of what? Side angle side. This one doesn't ask you to do that. Several problems I know on the test ask you, give a reason why these triangles are congruent or why you know this. A good reason is something like side angle side or angle side angle or whatever. Name this triangle over here for me. RQY. The R over here matches up to what over here? T. W. What's the Q match up to? Q. What's the Y over here match up to? T. Or it could match up to W. With these being, what kind of triangles are these two? Isosceles. Does it really matter how they match up?
Well, the answer.
All right, but for the answer, it's going to matter. So we could have it either of these two ways. Is that one of the answers on here? D. Does everybody agree with that? Well, it's kind of backwards, doesn't it? YQR. YQR matches up to. No, it doesn't. TQW, so it's got them backwards from what we wrote. But that's still correct. Next question. that to us. Wonderland.
Yeah.
With their rainbows and unicorn. Gavin's been there before, apparently.
Yeah, I think so.
I'm always there every time. Except for Spanish. I don't.
Why don't you want to be in my class?
No, I'm saying I don't want to be in Spanish.
Oh.
I want to be in.
You want to be in Wonderland in Spanish? You made it
Yeah.
sound like you wanted to be in Spanish.
No. Nine.
9?
Yeah.
Number nine is a little more difficult. Tell me something that we know in this picture. And I'll stand up here for the last 10 minutes if nobody tells me anything.
Vertical angle is 62.
That's 62 down there, we'll fill that in.
The bottom right angle is 50.
Those two were congruent, so that has to be 50.
B is 5x. Y.
That's true. That could go up there. Let's fill D in with something different.
Oh, that's just.
Something that we could find that's a little easier.
Is it 68?
68, does everybody agree with that?
Yeah.
Now, what's 5x plus y have to equal then?
68.
68. What else do we know? Don't look at my triangles because they're not drawn correctly. What's true about these two triangles? Supposed to be congruent, aren't they?
Yes.
My picture doesn't look like it. What do you know about segment EB? What do you know about segment EA? 8. 8, right?
Yeah.
Because it's got to spin around. So what's x plus 3y have to equal? 8. Can you solve this equation? Can you solve this equation? Can you solve the two of them together? Yeah, you got taught that in last year in algebra.
E equals 118.
There's no angle E, but I'll put it out there since I know what you're talking about.
No, it's not.
No, there's no angle E because if you say angle E, I don't know which angle you're talking about. How many
thought
letters?
that was just that angle.
How many letters to name this angle?
B, E, C.
C.
Say EEC.
I said B, E, C.
What do you have to do to solve this? Pick a variable, x or y.
Y.
Y. How do we get those y's to be opposites of each other? Close. -3. -3 times 5x is -15x. -3 times y is -3y. Somebody help me out. What's -3 times 68? -204. We add them straight down. 1x and -15x give me Negative 14x, the y's cancel out. 8, negative 204, give me how much?
Negative 196.
Divide both sides by negative 14. What's x equal?
14.
How are we gonna find y?
Plug 14 in for x.
So if I go to this equation, we knew that equaled 8. So 14 plus 3y has to equal 8. Subtract 14. 3y equals negative 6. Divide by 3. Y equals negative 2. Looking back at the problem, this is one of them where I underlined that statements word, didn't I? So what's that probably telling you?
More than one.
More than one answer. Letter A says the value of y is negative 10.
No.
So mark that one out, that one doesn't work. Letter B says angle BEA is congruent to angle DCE. Angle, we should probably plug back in here and find these angles, shouldn't we? How much is this angle? 5, what's 5 times 14? Oh, we don't need to do that. How much is that angle? 68.
Wait, is the answer?
I don't know. Angle BEA, where's angle BEA at?
Bottom.
That's that angle right there, right? Is congruent to angle DCE.
No.
So B doesn't work, so mark it out. Triangle EBA, triangle EBA. So we know that E matches up to what in the top triangle? E. B matches up to what? D. And A matches up to C. So does that one work?
Yes.
So one of the answers is
C.
C. The value of X is 14.
Yes.
So another answer is D. Letter E. Angle BEA, that's this angle, is congruent to angle DEC. That's true. So that one works. E works also. Then triangle CDE, starting here and going this direction. CDE, C matches up to, what should C match up to in the other triangle? A, does it in the, so what's the answers?
CED.
Whatever they said.
Now we will
Yeah, I want C now, I want what that angle is and what that angle is. You don't have to write all that, just tell me, this angle 30 degrees, this angle 180 degrees, whatever the answers are. What do you know about those two angles? Yeah, no parallels to that. We know about 3 angles of a triangle. We know about 3 angles of a triangle. So that plus that should equal.
Mr. Ebersole,
So that, huh?
72 to 75.
So then you just write, once you figure out what X is, you're gonna take X. Stick it back in here, so if X comes out to be 5. 2 times 5 is 10 plus that is 6. So that angle is 16. That's what you write down.
Mr. Ebersole, 72 to 75.
Pick one.
They're all the same picture.
Yeah. They just have to add up the numbers, they don't have to always be the same. They could be the same, but they don't have to be. Is that right?
Yeah, and then there's,
So that counts as 4, right?
Yeah.
72.
That's an F there.
Yeah,
Or it's that say 35 degrees?
yeah.
The F right here.
A, B, and B, S.
Yeah. And then it tells us AFD is 100.
So that's sort of hard to mark. That's all of this together.
A, B, F.
So this is isosceles. So what do we,
CDF.
so what do we know about these two angles? So these two are congruent. We ever find it?
CDF is a equilateral.
CD. So this angle's 60, that angle's 60, that angle's 60. So we can find this now. What's 60 plus 35? We gotta hurry. 95, subtract that from 150.
55.
55. That angle's 55. What's this angle over here then? Three angles of a triangle have to add up to, so 55 plus 55. So that's 70 up there. Let's see, anything else that they told us? We can find this angle. What do we know about all 4 of these angles together? So if all of those 3 together is 150. What's this angle? Now, let's see, angle CDF, CFD, sorry, we know that one. Hey, is that all of them? Do me a favor and grab a paper towel. It says give a reason, you know, like side angle, something like that. 20 problems, 20 multiple choice, 20 short answers. Move it into it.
Stop, right now, stop right now. I swear to God, again. I swear to God. Okay,
Well, did you figure out most everything?
I'm nice to you.
Do we get more extra credit if we do the whole thing?
I might get some extra points if you do the whole thing.
Yeah, I'm gonna need it, especially coming to the 12 groups. See, that's the thing I'm not really good at. I'm just saying
Real math, like the ones with numbers. I gotta
Yeah, real
all my
math.
notes and then I should be.
You'll be all right.
Yes.
We were on using notes too. Your phone on your lap.
I wonder how that.
Well, you say yes when I ask you that.
I didn't hear you. It was on your chair. And I smacked it on your leg.
Yes, but it was just in your mind.
Someone must have put it there.
Brianna, am I gonna have to stand beside you each day at the end of class so these guys don't act like
They won't have your file.
They won't?
I tried.
Let's go.
Thank you.
See, I'm nice.
Well, what was the point? What'd you get out of that?
being nice would not be doing it at all.
Dylan just slammed me against the table.
I dropped a bunch of note cards.
It wasn't the first time. 5-star.
Have a good day, Gavin. Have a great day, James.